Our project is a look for Tesla's nuclear vehicles in 2015. Our teammates are 胡耀、李天文、陈雨婷、王丹、蒋国琼. Our contents has 7 parts. The first, introduction of Tesla. Second, diagnosis. Number 3, identifying key drivers using a SWOT analysis. Number 4, application scenarios. Number 5, storylines. Number 6, problem identification. Number 7, suggestions or solutions. And first, we will see the introduction of Tesla. And since its founding in 2003, Tesla's mission has been to accelerate the world's transition to sustainable energy. Tesla is building a world powered by solar energy running on batteries and transported by electric vehicles. And Tesla has 4 impacts. They are environmental impact, product impact, people and culture, and supply chain. And let's say one by one. And the first, on environmental impact, Tesla has a 5-step plan towards sustainable energy, and its electric vehicle sold is number 1. And the second, Tesla's design and manufacture of fully integrated energy and transportation ecosystem. And the third, Tesla's diversity, equity, and inclusion team use a people-first and data-driven approach. And the last, in the long run, the transition to sustainable energy will reduce global mining and extraction needs. And Tesla has many products. They are vehicles, charging, and power, and they have many different kinds of products that meet the client's expectation. And the second part, we will look at diagnosis. We will share the program. In the future, all automotive technology is currently emerging that will take vehicle power to unprecedented heights and lead the way in the future of travel. The core element of the technology is nuclear energy, an energy source that is considered to have unlimited potential at the same time. However, the application of nuclear energy comes with great challenges and risks. And our title is Model N, a new generation of clean energy and super energy vehicles. And we have shorter and longer objectives. And the shorter objectives. In 2041, design a conceptual model of a nuclear power vehicle. In 2042, nuclear powered vehicle batteries to address safety, fuel supply, and management issues. 2043, nuclear powered vehicle infrastructure development. 2050, market introduction of nuclear powered vehicles. In the long term, our objective is 70% market share of nuclear powered vehicles. Our domain is automotive, and time horizon is 2050, and our territorial scope is automobile energy. And then we make the PESTL analysis. Political and many governments provide various policy support the nuclear cars, such as tax incentives and vehicle purchase subsidies, and for the economic development, the per disposable income of the global residents has been rising. And the third, social. Since entering the 21st century, the popularity of automobiles has been increasing. And the fourth, technology. Nuclear energy can provide a stable supply of electricity for a long time. The fourth, many countries proposed a lot of measures about carbon emissions, and the sixth, environmental contribute to low carbon and environmentally friendly transport.
Regarding the third part, which is identified key drivers, we use the SWOT analysis. What is SWOT? SWOT analysis ability to identify the identified strengths, weaknesses, opportunities, and threats. Why do we use SWOT? It is used for the compositions, strategy planning, providing the reliable data for smart decision and optimizing results for the better profitability and low risk. Let's take a look at the SWOT analysis chart for 2050 regarding nuclear-powered vehicles. About the strengths. First, nuclear-powered offer the unique advantage like high efficiency and energy density. Secondly, adopting the nuclear technology in Tesla means improved efficiency, safety, and cost effectiveness. Thirdly, Tesla's strong financial and technological resources combined with its skilled team position it well to be pioneering nuclear-powered vehicles. The nuclear-powered vehicles face the technology challenge like the insurance safety, cost effectiveness, and downside reactors. Secondly, market acceptance is tricky due to the public safety concerns and the need to comply with the stringent regulations. Thirdly, infrastructure issues like the developing a nuclear fuel supply chain and establishing charge facility requires significant incitement. Opportunities, including government support through the incentives and policy, rising demand for green transport due to the environmental concerns, and technological breakthroughs. Advances in nuclear technology are essential decarbonization and cost effectiveness deployment. Integrating sustainable energy is vital to stability, cost reduction, and efficiency. Threats including competition from the electric and hydrogen vehicle, policy and regulatory risk like subside change and emission standard, and environmental and social concerns about the nuclear energy impact. Next, we use the cross analysis. Strengths, weaknesses, opportunities, and threats are compared with each other to identify key uncertainties. Over SWOT cross analysis reviews. Strengths and opportunities show nuclear power the efficiency align with the demand for sustainable energy boosted by the government support. Strengths and threats indicate competition for electric and hydrogen vehicles and the need to manage resources against regulatory challenges. Weakness and opportunity focus on overcoming technical hurdles and improved market acceptance through the education and publicity. Finally, weakness and threats highlight the need to address the technical and infrastructure countries taking cues from the Tesla approach in the electric vehicles. Finally, we identify three key factors. These three traits interact and influence each other. Government policy support provides the ground for technological innovation, while increased environmental awareness enhance market acceptance of the nuclear-powered vehicle. Synthesizing these effects and developing strategies accordingly will be critical to the success of nuclear-powered vehicles in the clean energy market.
Now I'm talking about part 4, application scenarios. Using the 2x2 scenario matrix method for reasonable nuclear-powered vehicle development scenarios in 2050 are generated based on social behavior and technology. The metaphor of a ship is used to name the scene. The first scenario's description is smooth sailing, located in the upper right corner of the matrices. Is what happens when society truly appreciates nuclear-powered vehicles, resulting in the need for high technology, at the same time maintaining innovation in nuclear-powered vehicle also requires breakthrough technologies that can bring significant positive impacts to users. In the situation, our ship is sailing smoothly at the sea without any obstructions, taking us to the
destination that we want to reach. This is the most favorable scenario out of the other three scenarios. The second scenario, think or swing, located in the upper left quadrant, is where society truly appreciates nuclear-powered vehicles, which makes the demand for these technologies high. However, nuclear-powered cars cannot produce breakthrough technologies. This makes nuclear-powered cars unable to produce breakthrough technologies. Nuclear-powered cars are at a disadvantage in the market. This means that nuclear-powered vehicles must slowly and carefully introduce new technologies to the market, considering how to bring the product to market so that it can add a value. The third situation is that port move casually in the lower right quadrant and is a situation where society doesn't really recognize or consider the benefits of nuclear-powered vehicle to be important. Maybe the public still cannot admit that nuclear-powered cars bring safety and convenience to life. So what we have to do is increase our publicity on the benefits of nuclear-powered cars and introduce them in more detail. Comparisons with competitors' products emphasize the demand for nuclear-powered vehicles. The fourth scenario is drawing out weaving, which is in the lower left corner of the quadrant, is a situation where society doesn't have high demand for nuclear-powered vehicle, and there is not enough technology to promote its innovation. In this case, it is first necessary to analyze whether the advantages of producing nuclear-powered vehicles outweigh the disadvantages, and secondly, to promote public demand for nuclear-powered vehicles. It is also necessary to recruit more capable technical personnel to participate in research and development.
I'm excited to share about part 5, creating storylines. There are 4 storylines. The first is smooth sailing. Imagine the year 2050, where society's appreciation for nuclear-powered vehicles has reached unprecedented heights, triggering a massive demand for high-tech solutions among the public. Car manufacturers seize the opportunity and launch the various models of nuclear-powered vehicles. Government and private collaboration establishes dedicated lanes, charging stations, and grid support. However, in this scenario, there are still issues that need careful attention. For instance, the outstanding safety performance of nuclear-powered vehicles is partly due to the detailed and thorough regulatory system to ensure their infallibility. Therefore, the city's infrastructure needs constant updating and maintenance to support these high-tech vehicles. Secondly, sink or swim. In the sink or swim scenario, the demand for nuclear-powered vehicles is growing as people seek more environmentally friendly and efficient modes of transportation. However, tech faces unprecedented challenges, complex nuclear systems, extreme safety requirements, and environmental research and development costs. Therefore, the government, in collaboration with automakers, launched a pilot project for nuclear-powered vehicles. Volunteers enthusiastically sign up, providing valuable feedback, including areas for improvement such as response, speed, and comfort. Despite the challenges, they remain optimistic that continuous testing and improvement will drive society progress. Thirdly, airports move consciously. In the airports move consciously scenario, we witness a stark contrast between the maturity of technology and society's hesitation. This contradiction mainly stems from the public's traditional notions about nuclear power, concern about safety and environmental friendliness, and general hesitation towards new technologies. To its concerns, the government plans education initiatives like lectures, car shows, and media campaigns. Experts will explain technique principles. Collaboration will schools integrate nuclear tech into education, fostering awareness among the younger generation. Furthermore, municipal government must collaborate with experts, environmental groups, and car manufacturers to establish a transparent information sharing platform. Lastly, drowning not waving. In this scenario, nuclear-powered vehicles face the dual challenge of low societal demand and insufficient technological capability. To change this, the government formed a diverse team for a detailed analysis of nuclear vehicles. Despite challenges, they defined significant benefits in reducing emissions and providing sustainable energy. To enhance public awareness, the team collaborates with various entities for educational activities. Simultaneously, recruiting skilled technicians accelerates innovation. Gradually, public attitudes towards nuclear-powered vehicles have become increasingly positive. Simultaneously, advancements in research and development enhance the safety and economic efficiency of nuclearly powered vehicles.
In this section, I will show the problem that Tesla will face in the development of nuclear car in 2015 and how to solve them. The extension and development of nuclear power car is influenced by a variety of technical, economical, social, and challenges. The first problem is technical, addressing seven technical challenges such as sorting and the disposal of nuclear waste is essential for the development and upkeep of nuclear power car. For example, nuclear energy at the summit is millions of times more powerful than the heat release in chemical reactions. For example, uranium-235 products about 200 million electron volts through nuclear fission, while carbon in a chemical reactions yet only 4.1 electron volts. Another exception is the control of nuclear reactors, which are more difficult to control than chemical reactions. Common types of reactions around the world, including pressurized water reactions, boiling water reactions, and pressurized water reactions. Disposal-saving missions, academical such as leak and explosion, as well as very accident involving nuclear powder submarines, have occurred many times before. In addition, the disposal of nuclear waste is also a headache. There are no very effective ways to effectively use nuclear waste, or the car is too hot. The second problem is cost. The development, construction, and maintenance of nuclear power car can be expensive, potentially limiting the competitiveness in the market. The utilization of nuclear reactors typically involves submitting upfront technical support. The cost associated with building and operating the reactor, as well as expensive release to nuclear waste reprocess and reactor shutdowns. The third problem is that of regulations and promise. Nuclear power car face rigorous regulatory process overseen by nation and international authorities. including the International Atomic Energy Technique, with global legal restriction and adheres to the Nuclear Non-Proliferation Agreement to prevent the spread of nuclear weapons. In addition, international cooperation is also a problem. International collaboration is essential for developing nuclear power car, a technical covering uncommon in the market, as atomically primarily focus on alternatively renewable energy solutions, with numerous challenges requiring attention in the development. Taking into account the issue raised above, we put forward the following suggestions or solutions. Firstly, employing sustainable methods for nuclear waste management, ensuring secure storage and dispose. Invest in reprocess technology to recover 95% of uranium from space fuels, reducing long-term radioactivity and waste waters. The UK, France, and Russia are adopting civilizing nuclear fuel recycling, with China planning to do so. Additionally, incorporate advanced reducing protecting materials in the design from effective shielding in normal and accident scenarios, and for future advancements beyond the limitations of traditionally having protections. Thank you for listening.